Hi, I'm Sahiti Katula. I'm presenting a lecture on anomaly detection. What is anomaly detection in machine learning? Anomaly detection is identifying data points in data that don't fit the normal patterns. It is the process of finding outliers in a given dataset. Outliers are the data objects that stand out amongst other objects in the dataset and do not conform to the normal behavior in the dataset. Finding and identifying outliers helps to prevent fraud and network intrusions that can compromise your customer's company. Now let's talk about how anomaly detection works and what machine learning techniques you can use for it and what benefits anomaly detection with ML brings to the business. Before talking about anomaly detection, we need to understand what an anomaly is. Generally speaking, an anomaly is something that differs from a norm, a deviation, an exception. In software engineering, by anomaly, we understand a rare occurrence or event that doesn't fit into the pattern and therefore seems suspicious. Some examples are error in the text, sudden rapid drop or increase in the temperature. And common reasons for outliers are data processing errors, noise, fraud, attacks, etc. For example, if large sums of money are spent one after another within one day and it is not your typical behavior, a bank can block your card. They will see an unusual pattern in your daily transactions. This anomaly can typically be connected to fraud since identify thieves to steal as much as money they can while they can. And once an anomaly is detected, it needs to be investigated or problems may follow. Now let's see what kinds of anomalies or outliers machine learning engineers usually have to face. Global outliers. When a data point assumes a value that is far outside all the other data point value ranges in the dataset, it can be considered a global anomaly. In other words, it's a rare event. For example, if you receive an average American salary to your bank accounts each month but one day get $1 million, that would look like a global anomaly to the bank's analytical teams. Contextual outliers. When an outlier is called contextual, it means that its value doesn't correspond with what we expect to observe for a similar data point in the same context. Contexts are usually temporal, and the same situation observed at different times can be not an outlier. For example, for stores, it's quite normal to experience an increase in customers during the holiday season. However, if a sudden boost happens outside of holidays or sales, it can be considered a contextual outlier. Collective outliers. Collective outliers are represented by a subset of data points that deviate from the normal behavior. In general, tech companies tend to grow bigger and bigger. Some companies may decay, but it's not a general trend. However, if many companies at once show a decrease in revenue in the same period of time, we can identify a collective outlier. Why do you need machine learning for anomaly detection? The reason is that majority of companies today that require outlier detection work with huge amounts of data like transactions, text, image and video, content, etc. You would have to spend days going through all the transactions that happen inside a bank every hour, and more are generated every second. It is simply impossible to drive any meaningful insights from this amount of data manually. Moreover, another difficulty is that the data is often unstructured, which means that the information wasn't arranged in any specific way for the data analysis. For example, business documents, emails, or images are examples of unstructured data. To be able to collect, clean, structure, analyze, and store data, you need to use tools that aren't scared of big volumes of data. Machine learning techniques in fact show the best results when large data sets are involved. Machine learning algorithms are able to process most types of data. Moreover, you can choose the algorithm based on your problem and even combine different techniques for the best results. What are anomaly detection methods? There are different kinds of anomaly detection methods with machine learning. Supervised. In supervised anomaly detection, a machine learning engineer needs a training dataset. Items in the datasets are labeled into two categories, normal and abnormal. The model will use these examples to extract patterns and be able to detect abnormal patterns in the previously unseen data. In supervised learning, the quality of the training dataset is very important. There is a lot of manual effort involved since somebody needs to collect and label examples. Unsupervised. Artificial neural networks allow to decrease the amount of manual work needed to pre-process examples. No manual labeling is needed. Neural networks can even be applied to unstructured data. Neural networks can detect anomalies in unlabeled data and use what they have learned when working with new data. The advantage of this method is that it allows you to decrease the manual work in anomaly detection. Moreover, quite often, it's impossible to predict all the anomalies that can occur in the dataset. Think of self-driving cars. For example, they can face a situation on the road that has never happened before. Putting all road situations into a finite number of classes would be impossible. This is why neural networks are priceless when working with real-life data in real time. And the last one is semi-supervised. Semi-supervised anomaly detection methods combine the benefits of the previous two methods. Engineers can apply unsupervised learning methods to automate feature learning and work with unstructured data. Machine learning algorithms for anomaly detection. Multiple machine learning algorithms can be used for anomaly detection depending on the dataset size and the type of the problem. K-nearest neighbors. KNN is a supervised ML algorithm often used for classification. When applied to anomaly detection problems, KNN is a useful tool because it allows to easily visualize the data points on the scatter plot and make anomaly detection much more intuitive. Another benefit of KNN is that it works well on both small and large datasets. Instead of learning normal and abnormal values to solve the classification problem, KNN doesn't perform any actual learning. So when it comes to anomaly detection, KNN works as an unsupervised learning algorithm. A machine learning expert defines a range of normal and abnormal values manually, and the algorithm breaks this representation into classes by itself. DB-scan. This is an unsupervised ML algorithm based on the principle of density. DB-scan is able to uncover clusters in large spatial datasets by looking at the local density of the data points and generally shows good results when used for anomaly detection. The points that do not belong to any cluster get their own class, so they are easy to identify. This algorithm handles outliers well when the data is represented by non-discrete data points. Support vector machines. SVM is also a supervised machine learning algorithm often used for classification. SVMs use hyperplanes in multi-dimensional space to divide data points into classes. SVM is usually applied when there are more than one classes involved in the problem. However, in anomaly detection, it is also used for single class problems. The model is trained to learn the norm and can identify whether unfamiliar data belongs to this class or represents an anomaly. Bayesian networks. So it enables ML engineers to discover anomalies even in high dimensional data. This method is used when the anomalies that we are looking for are more harder to discover and visualizing them on the plot might not produce the desired results. What is anomaly detection used for? Now let's see how anomaly detection can be used in practice. Intrusion detection. Cybersecurity is a key for many companies that work with confidential information, intellectual property, and private data for their employees and clients. Intrusion detection system monitor the network to detect and report potentially malicious traffic. IDS software notifies the team if suspicious activity is detected. Some examples are softwares by Cisco System and McAfee, etc. Fraud detection. Fraud detection with machine learning helps to prevent activities aimed at obtaining money or property unlawfully. Fraud detection software is used by banks, credit organizations, insurance companies, etc. For example, banks check loan applications before making a decision. If the system detects that some of the documents are fraud, for example, that your tax return doesn't exist in the system, it will notify the bank employer. Health monitoring. Anomaly detection systems are incredibly helpful in health care. They help doctors with diagnosis, detecting unusual patterns in MRI and test results. Usually, neural networks that have been trained on thousands of examples are applied here, and sometimes they give a more accurate diagnosis than doctors with 20 years of experience. Defect detection. Manufacturers can lose millions in lawsuits supplying their clients if mechanisms are detailed that have defects. One detail that doesn't correspond to the production standards can cause a plane to crash, thus killing hundreds of people. Anomaly detection system that use computer vision can detect if the detail has a defect even among thousands of other similar details on the belt line. Moreover, anomaly detection systems can be connected to the mechanisms to monitor internal systems such as engine temperature, fuel levels, and other parameters. Finally, the conclusion is anomaly detection is identifying data points in data that don't fit the normal patterns. It can be useful to solve many problems including fraud detection, medical diagnosis, etc. Machine learning methods allow to automate anomaly detection and make it more effective, especially when large data sets are involved. Some of the common ML methods used in anomaly detection includes LOF and Bayesian networks, etc. Thank you so much.